All right, hello and welcome. Today, we're going to dive into the world of physics and engineering, but maybe from a perspective you haven't considered before. We're talking about the incredible technologies of Aboriginal and Torres Strait Islander peoples. We're going to see how this ancient knowledge absolutely mastered the fundamental forces of our world to create tools that are just, well, they're brilliant. So let's start with a mystery we've all probably wondered about. The boomerang. You've seen it, right? This curved piece of wood that just magically comes back to the person who threw it. It almost feels like it's breaking the laws of physics. But of course, it isn't. It's mastering them. And asking how it does that? Well, that's the perfect way to jump into this whole topic. And that's really the key thing to remember here. The science we're talking about today, it wasn't cooked up in some sterile lab by people in white coats. Nope. This was science born from thousands and thousands of years of careful observation, of trial and error, and of a deep, deep understanding of the natural world to solve very real problems, for survival and just making life more efficient. Okay, so let's start with one of the most fundamental things you could apply physics to, making the hunt more effective. And this is where we see some truly next-level engineering at play. First, let's do a quick Physics 101 on a concept you probably already know. The lever. It's a simple machine that gives you what's called a mechanical advantage. Think about using a crowbar to lift something heavy, or even just a simple seesaw. By applying a little bit of force over a longer distance, you can multiply that force to move something huge. It's a core concept in all of engineering. And here is that exact principle in action. It's called the woomera, or a spear thrower. Now your arm by itself, that's already a lever, but it's a pretty short one. The woomera is this brilliantly simple tool designed to do one thing: extend the length of that lever by a lot. So what's the payoff? Well, by extending that lever, the very tip of the woomera, right where the spear sits, is moving way, way faster than your hand ever could. And all of that energy gets transferred directly to the spear. We're talking a massive increase in speed, distance, and power. It's such a simple device, but it's an absolutely devastatingly effective application of physics, a total game changer for hunting. Okay, so from leverage and force, let's shift gears and go back to that mystery we started with, the boomerang, and take a look at the mastery of aerodynamic flight. Right, back to the boomerang. If you throw a stick, it just flies in a simple arc, right? Gravity pulls it down, end of story. But a boomerang follows this wild, curved path through the air. So what's going on? What are the special forces at play that make it so different? This chart breaks it down perfectly. It's not just one thing, it's three forces all working together. So first, each wing is shaped like an airplane wing. It's an airfoil. As it spins, that shape generates lift. But the real secret sauce is in the spin. See, the wing at the top that's spinning forward is moving faster through the air than the wing at the bottom that's spinning backward. This creates unequal lift. And that imbalance is what forces the boomerang to constantly turn, creating that amazing curved flight. But check this out. This is where the engineering genius really shines. Not all boomerangs are meant to come back. Look at this comparison. The returning boomerang we all know is a pretty specialized tool. The hunting boomerang? That's a completely different beast. It's heavier, flatter, and built to fly straight and hit hard. This isn't accidental. It shows a deliberate, sophisticated manipulation of aerodynamics to get two totally different results. And this deep understanding of forces wasn't just for things you could throw. It was also used to create some incredibly clever and long-lasting stationary structures. I mean, just look at the design of these ancient fishing traps. These are not just simple walls. They're complex structures, often made of stone, that are precisely engineered to work with the forces of nature. They use the power of the tides and the natural currents to basically funnel fish right into a holding pen. It's a passive, totally sustainable, and super effective way to use hydrodynamics. Just brilliant. And you see that same depth of knowledge in architecture, too. I mean, the principles on this slide for building shelters, these are the same things they teach in modern engineering courses. Things like distributing weight so the structure doesn't collapse, choosing exactly the right materials for strength, even shaping buildings to be more aerodynamic to handle strong winds. It all points to this incredible, practical understanding of structural forces. So when you step back and look at all these examples together, what's the big picture? What does it all tell us? Well, you start to see this consistent, really sophisticated, and ancient legacy of scientific knowledge. This quote here from our source material really just nails it. This isn't some new age reinterpretation of the past. It's a clear recognition of a deep, long-standing history of applying science in First Peoples cultures, in their tools, their hunting methods, their fishing, and their construction. And this is so important. This knowledge didn't just exist in a little box labeled physics. No way. The science that went into designing a boomerang or a woomera was part of a much bigger, holistic system. It was all connected to a deep understanding of the seasons based on astronomy and a profound knowledge of ecology, knowing exactly which wood to use for which tool and the right time to hunt or fish. It's all one interconnected web of knowledge. And that kind of brings us to our final thought for today. As we're all looking for more sustainable ways to live on this planet, what can we learn from this incredible legacy? I mean, this is a legacy not just of brilliant engineering, but of science that has been proven to work in harmony with nature for tens of thousands of years. It's a really powerful question to think about. Thanks so much for joining me.